You know, your body is run by this incredible invisible command system. It's a whole network of microscopic switches, and they control literally everything, from how fast your heart beats to how you breathe. Today, we're going to dive into two of the most important ones out there, the alpha and the beta receptors.
So, think about it for a second. How does your body know whether to hit the gas pedal or the brake pedal? In one moment, you need to tighten up your blood vessels, right? And in the very next, you might need to relax and open up your airways to catch your breath. How does it get it right every single time? Well, the answer lies in a really beautiful and surprisingly simple system.
So, how does this whole control system actually work? Well, it's all about these things called pharmacological receptors. The easiest way to think of them is like tiny docking stations on your cells, just waiting for the perfect signal to come along and flip a switch.
Now, we're going to focus on the two main players in this whole operation. They're part of the same big family, but they have jobs that are basically polar opposites. So let's meet Team Alpha and Team Beta.
All right, let's get right into the great divide. Because understanding the one big thing that alpha does versus what beta does, that's the absolute key. They are two sides of the very same coin. And honestly, at its core, it really is this simple. Alpha receptors, their job is constriction. I want you to think of them as the body's squeezers. They tighten things up, like your blood vessels. On the flip side, you've got the beta receptors. Their job is dilation. They're the relaxers. They open things up, making passages wider. So squeeze versus relax. That's it. That's the fundamental conflict between the two. But it gets even more specific and honestly, even cooler, especially when you look at Team Beta. They've got specialists, you see. And there is a ridiculously simple way to remember exactly where they work. It's a perfect little memory trick. First, just look at this number, 1. That's it. Why? Because here's a trick you'll remember forever. You have one heart. And that little fact brings us right to the beta 1 receptors. See the 1 in beta 1? That's your clue. These are the beta specialists found mostly in your heart. When you activate them, they get your heart working harder and faster. Simple, right? Beta 1, one heart. Okay, so if you're following that logic, what comes next? You guessed it, the number 2. And just like before, there's a reason, because you have 2 lungs. And this, of course, connects us directly to the beta 2 receptors. The 2 tells you exactly where to find them, your 2 lungs. Their job is to relax and dilate all those airways, making it way easier to breathe. So let's lock it in. Beta 1 for your 1 heart, beta 2 for your 2 lungs. Now, this isn't just a neat biology fact. This knowledge is the foundation for actual life-saving medicine. Because if we know which switch does what, we can design drugs that flip only the switch we want to flip. Let's look at a classic example, a simple asthma inhaler. So the source material gives us his perfect real-world case. Albuterol, which is the stuff in a lot of inhalers, is a bronchodilator agonist on beta 2 receptor. Okay, that sounds complicated, but let's break it down. Broncho just means airways. Dilator means it widens them. And agonist is just a fancy word for turning the switch on. So it's an on switch that widens your airways by targeting, you got it, the beta 2 receptors. So here's exactly how it works. When someone's having an asthma attack, their airways constrict. They get squeezed tight. They take a puff from their inhaler, the albuterol medicine travels right down to the lungs and seeks out only the beta 2 receptors. It hits that switch, tells the airways to relax and dilate, and just like that, they open back up. The result? You can breathe again. It's an immediate relief. So really, your body is in this constant balancing act. It's a tug of war between constriction and dilation, between alpha and beta. And just understanding that one simple opposition is the key to figuring out how so many critical body functions and medicines actually work. And here it is, your final cheat sheet all in one place. It's pretty elegant, right? Alpha constricts, it squeezes. Beta dilates, it relaxes. And the beta team has its specialists. Beta 1 for your 1 heart and beta 2 for your 2 lungs. That's the whole system right there. You know, this whole idea of targeting specific receptors is a cornerstone of modern medicine. It lets us be incredibly precise, turning one system on while leaving another one completely untouched. And it really makes you wonder, now that we know how to flip these tiny individual switches with such amazing accuracy, what other complex systems inside of us are we just beginning to understand and maybe even control?